A casino die must be accurate to within 6/10,000ths of an inch, roughly 1/5 the width of a human hair. Fall outside that tolerance, and billions of dollars in wagers have no guarantee of true randomness. The die in your board game right now wouldn't even come close. Hidden air voids and uneven density are quietly skewing every throw. What it actually takes to build a perfectly fair die starts long before anyone rolls it. Standard board game dice are manufactured through high-volume injection molding. In this process, molten plastic is forced into a mold, cooling rapidly from the outside in. This uneven cooling rate inevitably creates microscopic air pockets and internal stress fractures. While two dice may look identical on the surface and weigh exactly the same on a consumer scale, their internal density is highly unpredictable. A tiny void, completely invisible to the naked eye, shifts the center of gravity away from the geometric center of the cube. When rolled, the heavier side of the die is subtly pulled downward by gravity, while the lighter side, containing the void, is more likely to settle facing upward. In a casual home game, this slight bias goes unnoticed. But over thousands of rolls at a craps table, even a microscopic weight discrepancy of a few milligrams will skew the mathematical odds. For a casino, where profit margins depend on precise mathematical probabilities, these hidden structural defects represent an unacceptable risk. True randomness cannot exist if the material itself contains built-in physical bias. To eliminate the unpredictable voids of injection molding, manufacturers bypass molten liquid plastics entirely. They begin with solid, extruded rods of high-grade cellulose acetate. This polymer is selected for its stable molecular structure, exceptional optical clarity, and uniform density. Unlike cheap polystyrene, cellulose acetate can be machined as a solid block. This allows engineers to sculpt each cube using subtractive manufacturing, cutting away material rather than forcing it into a mold. This material choice is dictated by the extreme dimensional target required for casino play. Every single face of a casino die must be finished to a tolerance of 1/10,000th of an inch. To put that in perspective, a human hair is roughly 30 times thicker than this margin of error. At this level of sub-millimeter geometry, the die becomes a precision-engineered component, built to the same exacting standards as aerospace guidance systems or medical instruments. Achieving such rigorous standards requires absolute control over the physical medium. If the material warps, expands, or degrades under changing room temperatures, the microscopic tolerance is lost. Cellulose acetate resists these environmental shifts, ensuring that the cube remains structurally stable from the machine shop to the casino floor. This disciplined material control is the foundation of the manufacturing process, establishing a perfectly uniform block that is ready for the next stage of precision machining. The physical transformation of a raw extruded rod of cellulose acetate into a finished gaming instrument begins on the machine shop floor. Here, a machinist mounts the solid polymer bar into a precision cutter, slicing the stock into rough, oversized blanks. These initial pieces are only approximations of a cube, measuring slightly larger than the final 3/4 of an inch specification. Next, the blanks are loaded into a CNC mill. During this roughing stage, high-speed carbide end mills carve away the outer bulk of the plastic. This step is aggressive, stripping away material to bring the blank within a few thousandths of an inch of its final size. But CNC roughing alone cannot deliver the final surface quality or eliminate microscopic geometric errors. To achieve absolute squareness, the machinist transfers the blanks to a high-precision surface grinder. In this measured, tactile process, a grinding wheel gradually lowers by tiny increments, often just 2 microns per pass, gently sweeping across each face. This gradual shaving removes the highest points, squaring the block until all 6 faces meet at precise 90-degree angles. The finished blank, is no longer just a recognizable shape. It has become a balanced geometric instrument, ensuring every side shares the exact same starting condition. Drilling the pips into a blank cube removes physical mass, creating an immediate physical imbalance. A standard CNC mill carves cylindrical cavities into each face, but this subtraction of material is uneven. The sixth face, containing 6 hollowed pockets, becomes lighter than the opposite one face. This discrepancy shifts the center of gravity away from the geometric center of the cube, which would bias every roll. To preserve true randomness, manufacturers must restore perfect mass parity. Technicians backfill every drilled cavity with a specialized epoxy compound. This liquid filler is carefully formulated to match the exact density of the original cellulose acetate, which is 1.3 grams per cubic centimeter. Injected under pressure and cured, the epoxy solidifies into a state that is physically identical in weight to the surrounding plastic. Once the excess is shaved flat, the finished spots are visually distinct but structurally invisible to the laws of physics, keeping the center of gravity exactly where it belongs. At the quality control station, the manufactured cube must prove its geometric integrity before it ever touches a casino table. The choice of transparent cellulose acetate now serves a second important purpose. Under a polarized light source, an inspector scans the clear polymer body. Any internal stress fracture, microscopic air bubble, or density variation in the cured epoxy will bend the light, exposing flaws that opaque plastics would easily hide. Next, the inspector performs a manual evaluation, feeling for tiny burrs or surface blemishes along the sharp razor edges, but human touch only goes so far. To convert qualitative appearance into absolute proof, the inspector places the die under a high-precision digital micrometer and a coordinate measuring machine. These instruments measure each face to confirm the block meets the plus or minus 0.0001 inch dimensional standard. Even a deviation of a single micron, invisible to the human eye, results in immediate rejection. Only when every measurement matches these strict tolerances does the cube receive official approval, transforming a piece of machined plastic into a certified, mathematically unbiased instrument of chance. Approved dice transition from quality control directly into active deployment. Before hitting the table, each cube receives a laser-engraved serial number and casino logo. These markings authenticate the die's origin and prevent tampering rather than serving as decoration. To preserve the cube's neutrality, the laser cuts to a depth of less than 0.02 millimeters, ensuring the weight balance remains completely undisturbed. This precise depth keeps the center of gravity perfectly centered. Simultaneously, the edges are finished to a razor-sharp profile. Standard board game dice feature rounded corners that glide easily, but rounded edges alter settling behavior and can introduce systematic bias. Razor edges create sharp friction against the table felt, forcing a highly chaotic tumble with every bounce. This sharp geometry serves as a critical security feature that guarantees statistical randomness upon impact. Active play subjects sharp razor edges to continuous impact against table walls. Within 4 to 8 hours, this friction causes microscopic wear that alters the cube's exact dimensions. Casinos treat this wear as a performance failure rather than a cosmetic flaw. To maintain true randomness, quality control continues long after manufacture. After a single shift, the dice are retired from service. To prevent them from ever returning to the table, a technician defaces each die by drilling a small hole directly through the center of the 4 spot. This physical mark permanently ends their brief service life, protecting the mathematical integrity of every roll. In our increasingly digital world, these physical cubes remain the ultimate standard of trust. We rely on microscopic engineering to keep absolute chance completely fair. True randomness isn't born of luck. It is manufactured, one perfect micrometer at a time. Let me know your thoughts in the comments.